Okay, guys, we're going to get started here. First, like to say thank you to everybody who's jumped on this webinar. Appreciate everybody's time. Understand that everybody's probably got a lot of stuff going on, and just appreciate the opportunity to speak with you guys. My name is Joe Marinero. I'm a business development manager working for Catapult Sports. I've been with the company for 20 plus years, and I work specifically with Major League Baseball and a bunch of collegiate teams as well. We're going to take you through a quick PowerPoint presentation today. The bulk of the call today is going to be Ed Liggett speaking to you guys, but I'm going to kick things off today by just giving you a quick overview of who we are, Ed, if you would. So currently today, for those of you that are not aware, Catapult is the largest wearable company in the world. We have over 3,200 clients across 40 sports. I'm not showing you this slide necessarily to pound our chest and to say, look how great we are, but more just to show you that we've got a lot of technology built from a lot of sports that's shared, that carries over and crosses over, that's helpful into baseball, and we'll start touching on some of those things. I'm going to tee this presentation up to Ed. He's going to take us through some of the more baseball specific items. Just to give you a quick background, Ed Liggett, he was an academic GA and intern strength and conditioning coach at the University of Louisville, working in the Olympic weight room, specifically helping out with baseball. He worked at Louisville as a sports performance fellow. He used both Catapult and Polar for 6 teams in Olympic, including baseball, from 2014 to 2015. And then since 2015, he joined us as a customer specialist or applied sports scientist. And since 2017, he's worked specifically on our baseball and working with baseball algorithms and helping to develop those, developing baseball with Catapult Sports. So without further ado, I'll kick it over to Ed, and then we'll have a Q&A session at the end of this presentation.
Thanks, Joe. Just to confirm, everyone can see these slides that I'm clicking away on, yeah?
Yep, all good.
Sweet, thanks, Blake. Right, so what we're going to discuss today, originally the idea of the topic was going to be essentially how to address injuries in baseball using technology, obviously specifically Catapult technology, and that kind of morphed into a larger conversation of essentially load monitoring. Like Joe said, I've worked in the baseball realm as far as Catapult goes for the last 4 years now, 4 years plus, and some seeing and being involved in both baseball and several other sports ranging from basketball, football, that kind of stuff. There's a lot of interesting things that we've been finding as far as load management goes. Much more broad topic than addressing specific injuries, whether they're lower body, upper body, anything like that. So we kind of just morphed this conversation into more so load management. So one thing that I think is incredibly unique to baseball is that there are lots of types of load management. Obviously, if you don't know what load management is, that's essentially figuring out how much the athletes are doing, what volumes are they doing, what are they actually doing on a day-to-day basis, whether it's in the weight room, whether it's on the practice field, whether it's in an agility speed session, whether it's in competition, whatever it may be, figuring out what loads their bodies are going through, what stimulus they're being exposed to, and how that progresses or is managed over the course of time. Now, generally speaking, there's 2 types of load management. I'm painting with a pretty broad brush here, but there's internal load. So obviously your heart rate response, lactic responses, anaerobic responses, all that kind of stuff. And then there's external responses, essentially types of load, which are essentially, what are you doing? What's your outputs? What are your speeds? What are your physical outputs on the field? And when we talk about load, things to consider are obviously volume of, intensity of, and frequency of exposure of load. That being said, baseball is a unique sport in that there's multiple types of load. Jumping into Catapult, historically speaking, is a GPS technology way back when, was exclusively GPS. Works great for Australian sports where it was originated, which is essentially Aussie rules football, soccer, but sports where you don't necessarily cover ground constantly, it's a little bit less useful to rely on GPS-based technology. So the reason I mentioned that is that there's a lot of load in baseball itself that aren't specifically locomotor. There is obviously your outfielders need to run. You have base runners, especially in the a small ball approach in the collegiate setting. There's a lot more running focus and practices, obviously, but there's more importantly in baseball, there's load accumulated through swinging a bat and throwing a ball, whether it's throwing or pitching. The reason I mention these is it's important to be able to quantify how much they're doing and when. And the more we dive into baseball data specifically, uniquely more college as of late, we're seeing a lot of interesting trends over the course of the season. Now, obviously, historically with MLB, the largest spikes of injury usually occur mid-March when they start playing their actual games during spring training. And jumping into the collegiate realm, there's a lot of injuries and soft tissue soreness in fall ball. And knowing the cycle of collegiate sports, you jump from 8 hours of training, which is typically probably 3 with a coach or 3 with a position specialist, and then 5 with a strength and conditioning person, obviously give or take hours here, there, and then jumping into 20 hour and doing 20 hours of baseball for a week. That usually correlates to several multiples of more load from week to week, which is essentially a huge red flag as far as load monitoring goes. Essentially what I'm saying here is that you'll go from, accumulating, say, I don't know, if you're an outfielder, accumulating maybe a couple hundred yards of high speed running in a given week with your strength and conditioning coach to accumulating several thousand high speed yards over the course of a scrimmage weekend. That being said, it's important to be able to monitor what's the year look like, what's the season look like, where are there spikes in load, what is the program as far as what is the plan, and figuring out what specifically we're doing in those scenarios, what teams are doing, and then being able to modify a plan, or as we're seeing with some of our collegiate data, generating a plan as far as other aspects of baseball goes. Baseball is very historically pitch count heavy. Obviously, even the fans know going to a game, they put the numbers up on the top of the screen, what the pitcher's at as far as pitch count goes. There's obviously far more to it than live pitches in game. Being able to quantify how much a player is going into the cages and taking extra hacks before or after practice. We've seen guys come in and take an extra 100 swings before practice even starts when there's live BP and other cage sessions within the actual training session for that day, just because that's the nature of, motor development or of skill acquisition is obviously repetition. However, how much is too much? Is there a lower body injury that is being exaggerated or exasperated by the fact that you're increasing those loads without actually having exposure to how much these athletes are going through? And being able to quantify, obviously, all of those aspects of baseball has been incredibly eye-opening, and from our clientele that Joe kind of hinted at earlier on has been incredibly useful. So these fancy little graphs on the right here on this screen, as you can see, is a little bit of insight to what we actually can offer at Catapult, but that's on the top there, that blue and green is just pitch count and throw count. So I'll get into a little bit of that, how that works here in a second. Over the course of time, and then the orange graph is showing you swings by intensities, low, medium, or high over the course of a 2-month period, which is a fall ball snippet of data. And then that bottom graph is essentially a rehab player in a minor league organization and their high speed running exposures over the course of 2 months. The interesting thing to kind of always look at with these is trying to figure out what the plan is and how it's being executed. I won't really comment on these graphs specifically, but it's just incredibly interesting to see how that looks, and then putting that back to coaches, like, all right, what's the plan here? What can we do to kind of modify this and come up with a more succinct way to either ramp up or down or whatever it may be as far as load management goes there. Also, I forgot to mention this earlier on. If there's any questions, feel free to pop them into the chat. We have a section for it at the end, which will probably address it there, but we can always jump around at the end and go back to slides if there's specific questions here. As I hinted at on the last slide, within our baseball offering of metrics, we have a good amount of baseball specific metrics that are derived from the inertial sensors. Essentially what that means is you get them indoor, outdoor, wherever you may be. Obviously cages are inside or underneath a metal roof, which is obviously GPS independent. But essentially the way these works are the system essentially identifies, was there an event, a rotational event, using machine learned data, thousands of machine learned points. Is this a bat swing or a ball throw? Deviates those two. If it's a swing, you're done, great. You get all your metrics that come with that as far as intensities and accelerations and rotations. And then with throwing, it also deviates between, is this a throw or a pitch, based off of several characteristics that are a little bit of the secret sauce I can't really dive into in a group setting. And then what if it's classified as a pitch? We'll classify those even further. Is it a stretch delivery or a full wind-up delivery? The reason this is important is obviously there's variations of mechanics there, so it's important to compare apples to apples when you're comparing outputs as far as throw intensities, all that kind of thing. So that's just kind of a insight into how the actual algorithms work as far as the baseball specific stuff, as far as event identification. And then we can kind of jump into what we do with those once those happen. Now, obviously globally, step one for load monitoring is usually just a simple event count. Super easy to digest, figuring out, again, how much are you doing and when are you doing it? How many swings you take in a day, how many swings you take in a week, how many swings you take in a month, how's it going over the course of the off season? One of the nice things about Catapult is being able to track remotely. You give the unit to an athlete, they go to their home facility, they can upload their data and send it to you. You can keep their year-round tracking going. But essentially those event counts are usually step one, figuring out just how much they're doing. Banded event counts, so essentially bucketing those events, as I kind of hinted at 2 slides ago, into like a low, medium, and high threshold. All right, you're taking a lot of low intensity swings today. What is an actual swing intensity, in game? Are we mirroring those two? We've done a little bit of work in figuring out that the loads in batting cage sessions and loads in live BP are way different for a lot of our minor league data sets. Not necessarily a bad thing, but always important to know, right? So are we intending to replicate gameplay? If we are, here's how we can look at the variations in load per specific event. And then moving forward from that, obviously those load counts and those intensity counts as far as each event, we can get a little bit further into this newest suite of metrics. It's essentially movement profiling for both throwing and pitching as well as swinging. We can go in and say, all right, what is your lateral acceleration per delivery or swing? What's your vertical acceleration? And what's your anterior, posterior, so forward acceleration? And how does that change over time? So we have a good amount of fall ball data. This is obviously a very new metric suite. And this specific example seems to be popping up pretty repeatedly. So on the right, you can see there's kind of 2 very complicated looking graphs. They are not that complicated, but the top one is one pitcher for a specific outing. It's their longest outing or their big scrimmage, essentially at the end of fall ball. Actually, not sorry, not fall ball. This was spring. But anyway, so essentially this is their longest outing in that time period, seeing, all right, how does each individual pitch over the course of the outing change as far as lateral, anterior, and vertical acceleration? Obviously, I can lean in here a little bit. Forward is dark blue, vertical is green, and then lateral is light blue. You can see as the outing progresses, you can see there's a slow, I would assume it's fatigue. Obviously, this it would be a lot easier to call it fatigue if we had a heart rate sensor on this guy, but we didn't. However, over the course of the outing, you can see that there's a bit of a profile change or a drift in how he's delivering a pitch. Obviously, their unit sits at T1 of the spine, so it's not necessarily arm mechanics, but his rotational mechanics are changing over the course of that session. Interesting, not necessarily impactful. The step 2 of this that we can do is we can zoom out a bit and say, all right, longitudinally, how is their profile looking over time? So this is the same graph, but with the median value of lateral, vertical, anterior, posterior acceleration per event over the course of time. And the super interesting part that we're seeing really early on is that those signatures tend to match up. So the fatigue trend lines that we're seeing in the top graph, we're seeing those same trend lines over the course of a longer term time frame. Super interesting when it comes to load monitoring, tying it back in. Essentially what we're trying to do with this individual profiling is saying, all right, what do they look like when they're at their best, unfatigued, high intensity or game intensity settings? How does that change over the course of an outing, whether it's fatigue or they're focusing on a specific mechanic? Is it changing in the direction that we want to? And then if not, do we intervene? Or if it's changing the direction we want to, how do we make sure that we set up a flagging system to make sure that we're checking the right boxes for the day? So this is a very detailed example of how to do individual profiling. This same kind of concept is also applied pretty heavily to outfielders, as well as your collegiate base stealers. What's their acceleration looking like day to day? What's their acceleration? So in a collegiate setting, the practices are much more dense. There's a lot more base running, like rapid fire base running drills. How many base running reps can we take with minimal rest before we're compromising our acceleration intensity? We're essentially focusing more so on the conditioning aspect of it, whether as opposed to the quality of base stealing. Obviously, your base stealing is not necessarily ever happening in a fatigued state or aggressively fatigued state, but how do we make sure that we match that profile of the game? Are these guys, it's also a long season, are these guys staying fast as they were at the beginning of the season? Are they getting slower? And if not, do we need to intervene? And then using a various array of metrics, we can also kind of hone in on that. So if they're getting slower, are they doing too much? Are they doing too little? Going back to that first slide of, is the volume too high? Is the intensity too low? Or is the frequency of exposure too frequent? So these guys are kind of burning out, for lack of a more scientific term right now. So all of these load monitoring aspects kind of funnel into this individual profiling. And the more you can dive into this individual profile, you can understand how are these athletes moving. And then when those profiles change over time, does it require essentially intervention to avoid or mitigate injury risk or decrease performance? And then lastly, in addition to obviously healthy regular season monitoring, it's incredibly helpful using Catabolic data to be able to profile what a healthy athlete looks like. Obviously, the more specific you can get to individual athletes, the better. But essentially, what will happen is this slide is pretty unapologetically stolen from one of my colleagues at Catapult. So essentially, what we're doing is trying to figure out, all right, an athlete gets hurt, how do we get them back to healthy in a safe manner, right? Classically speaking, oh man, my text didn't carry over on this one. Classically speaking, typically your first stage, that first block, so 0 to 20 days, this is arbitrary, is usually spent with like a PT. All right, how do we, physical therapist, how do we get these guys physically moving? Very small volume, very small intensity. How do we get these guys moving again? PT usually hands it off to sports med or athletic training. And you can see over the course of time, the volume increases and the rate of volume also increases. So volume intensity goes up a little bit. Then that handoff typically goes over to strength and conditioning, where both volume and intensity increase even more so. And then you go back into the game setting, where there's obviously back to normal, essentially, exposures. So what's important here as far as monitoring what they're doing, which is first and foremost, is figuring out how are they responding, right? So is that ramp up from the 20 to 40 days with the athletic trainer too fast for them? Are they getting slower? Are their outputs decreasing? Are they showing, changes in mechanic that are completely different to their healthy profile prior to injury? So it's important to be able to kind of validate essentially the processes in place and then modify as needed. So obviously all of this is important to intervene and make an increased quality, I guess you could say, of decision making. So yeah, and then obviously you can set up various KPIs when it comes to catapult outputs. Obviously those median throwing intensities, the max velocities, max accelerations, swing intensities, all that kind of stuff. Being able to set up reporting and set up those things to kind of red flag, hey, this guy's not ready. He's not hitting 8% as max velocity. Maybe we don't progress him to the speed session or strength and conditioning section of his return to play program. So important to be able to kind of modify that as needed. And the thing that I am most excited about as well, this is with our new suite of Catapult metrics, comes the live monitoring. So essentially with our system, historically speaking, you can set up a receiver and a computer at the side of the field, and you can get your GPS-based metrics over the course of the session. How far is the guy running? How fast is he going? Historically, this is used in more than just baseball, but also in baseball to be able to top off guys who essentially haven't run fast enough for a day. So going back to that original slide, are your volumes of high intensity work there? Is your frequency of exposure there? If a guy hasn't gone over 90% of his max velocity for a couple of weeks, it's typically a red flag the next time he does go 90% of his max velocity because he just hasn't been there before. We've seen data sets where guys haven't 20-mile-an-hour guys haven't cracked 16 miles an hour for 16 days, have to go 20 miles an hour again in a game due to a long fly ball, whatever it may be, and their hamstrings light up, whether it's, obviously an injury or soreness, something negative happens there. So it's important to manage frequency of exposure. Obviously, historically with GPS, we could do that, still can, but I'm pretty excited with those swing, pitch, and throw counts as well as intensities now come through in our live tracking system to be able to kind of modify and intervene as needed. Having attended several minor league sessions and major league practice sessions, there is a microscope the players are under when they're actually throwing live pitches or throwing live off the mound. However, it's a little bit more loose when it comes to volume monitoring prior to that event. So obviously for every pitch they're throwing live off the mound, there's several other movements that are happening prior to that. So getting a snapshot of how much they truly did in an individual day, and then shutting them down if need be, or saying they might need more warm-up throws if they haven't hit the threshold that they want prior to getting on the mound. So being able to modify with live feedback is huge. This screenshot on the right here is my data. Because it's just giving it a little bit of a test run, but very excited about this. So those intensity numbers that you're seeing on the right, while they might be small, if you're leaned into your screen and try to find them, don't expect those numbers from real baseball athletes. I am several decades retired, but algorithms working well, and it's super exciting times to be able to kind of modify this and deploy that over the course of the spring, both collegiate and professional. So